Okay, so this problem reads, a football quarterback is moving straight backwards at a speed of 2 meters per second when he throws a pass to a player 18 meters straight downfield. The ball is thrown at an angle of 25 degrees relative to the ground and is caught at the same height at which it's thrown. What is the initial velocity of the ball relative to the quarterback? Okay, so here we have a case of projectile motion, balls being thrown 25 degrees downfield to a receiver. First step in our kinematics, we're interested in velocity, so this is a kinematics problem, is to identify our object. Well, that's that ball being thrown, right? Thrown straight downfield. If we identify our object as the ball, our next step, remember, is to identify both the initial, when do we start caring about the motion, and the final, when do we stop caring? Well, we start caring when he releases the ball. That quarterback, oops. I lost my cap. When we release the ball, and we stop caring when it's caught. All right, so that defines the motion. And we want to know what's the velocity relative to that quarterback when he throws that ball. Okay, so let's draw our picture. So here we have quarterback. Here's our ball. All right, and we're going to throw that ball downfield. We have to define the origins for both our horizontal and our vertical dimensions. So let's define the horizontal origin at the location of the ball. And let's define the vertical origin at the location of the ball. Okay. So we go to make our horizontal and our vertical list of variables, our players of motion. So we have x initial horizontal, x final horizontal, v initial horizontal, v final horizontal, our horizontal acceleration, and our time. And similarly, vertically, we have our initial vertical position, our final vertical position, our initial vertical velocity, our final vertical velocity, our vertical acceleration, and our time. All right. So where does the ball start? Well, it starts at the origin. So our initial horizontal position is 0. We know that player is 18 meters downfield. So we're going to get to 18 meters downfield as our final horizontal position. Now our initial horizontal velocity, we have to be careful. The quarterback's going to throw that ball to the right to that player downfield, giving it a horizontal velocity towards that player. But the quarterback's also running to the left. Remember that this quarterback is moving, velocity as quarterback, 2 meters per second to the left as I've drawn it. So at a negative 2 meters per second. So our horizontal velocity of that ball has to consider the fact that the quarterback is also moving because the ball's moving with the quarterback. So our horizontal velocity is going to be that -2 plus whatever velocity in the rightward direction the quarterback throws the ball with, the horizontal component of the ball. All right. What about our final velocity, horizontally? We know in two-dimensional motion that there's no acceleration horizontally in projectile motion. So our initial and our final horizontal velocities are the same. So we have -2 plus the horizontal velocity of the ball. Again, this is relative to the quarterback and relative to the quarterback. All right, and we don't have the time. What about vertically? Well, the ball starts at the origin because that's where I've defined the origin. It says it's caught at the exact same height that it was thrown, so it's also caught at the origin if it's caught at the same height. We don't know the initial vertical velocity, but this is going to be the vertical component of the ball. And again, that's relative to the quarterback. We don't know the final vertical velocity, except that we know that it's caught at the same height, which tells us that the initial and the final are the same, but in opposite directions. It goes up and comes back down, and when it reaches the same vertical height, it's going the same velocity as it did when it was thrown at that height. Our vertical acceleration is negative 9.8 meters per second squared because it's gravity, and we don't know the time. So this understanding, if you're not sure about that, do a problem where you are looking at what the initial and final velocities are relative to one another. If you know that the ball is going up and down, you can do a one-dimensional problem to prove that to yourself if you need. Okay, so what are we interested in? We're interested in the velocity of the ball, the true velocity of the ball. We want to know is what is the velocity of the ball relative to the quarterback? Well, we know that that ball is being thrown at 25 degrees at some velocity. So the horizontal component of the ball relative to the quarterback is going to equal the velocity of the ball times the cosine of 25. And the vertical component of the ball, or relative to the quarterback, is going to equal the velocity of the ball relative to the quarterback times the sine of 25. We're going to use that so that we can get the velocity of that ball. Okay. If that's what we want to know, then we need, I'm looking for my cap, but it's on the ground. We need to know both the horizontal and the vertical components to get the velocity of the ball. Or if I know one of them, I could get the velocity of the ball. So let's go after one. Let's go after the horizontal component. So I know my initial and final position. So I'm going to look at the equation that allows me to use initial and final position. Well, the acceleration is 0. So in the horizontal direction, that term goes to 0. We're left with 18 is equal, so this is horizontal, my x initial, which is 0, plus v initial, which is minus 2, plus the horizontal component of the ball, which is the velocity of the ball times the cosine of 25 times t. All right, so I'm going to simplify that. And I get 18 is equal to negative 2 plus the velocity of the ball times the cosine of 25 times t. But I need t to solve for that velocity of the ball. Okay, if I can't get t in the horizontal direction, I'll often go to it in the vertical direction. So let's take a peek at what happens if I look at the vertical motion. We'll use the same equation that we had before. So x final is equal to x initial plus v initial t plus 1/2 at squared. Well, my x final vertical is 0. My initial vertical is 0. My initial velocity is the initial velocity of the ball relative to the quarterback, which is the velocity I'm interested in, times the sine of 25 times t, plus 1/2 negative 4.9 t squared. Oops, 9.8. Not negative 4.9, that's what 1/2 9.8 is. I'm used to writing that. 9.8 t squared. So I'm going to simplify this. I'm going to bring this term over to the other side. These two zeros are going to go away. And I end up with 4.9 t squared, which is 1/2 negative 9.8, is negative 4.9. Bring that over. Is equal to v times the sine 25 times t. One of the t's might go away for me, so I have 4.9t is equal to v sine of 25. I still don't have t, but these are the same t's. So if I were to solve for t and plug it in to this equation, I should be able to solve for v. Let's see if that works. So I'm going to solve for t here. T is equal to 18 divided by negative 2 plus v times the cosine of 25. All right, I'm going to plug that in to this equation. So I end up with 4.9 times t, where t is 18 over the quantity minus 2 plus v cosine 25 is all equal to v times the sine of 25. Now I have a single equation which only has the velocity v in it, which is the velocity of the ball relative to the quarterback. That's what I want. So I can solve this equation for the velocity of the ball relative to the quarterback. So I have to do a little algebra here. If I do a little bit of algebra, what I like to do is maybe put in, excuse me, the values for sines and cosines. You don't have to at this point, but they're just numbers. And so I kind of like, and I'm a numbers girl, so I kind of like to put in those numbers. So we end up with 4.9 times 18 over minus 2 plus, and the cosine of 25 is 0.906. So plus 0.906 v. And that equals v times the sine of 25. And the sine of 25 is 0.423 v. Now I can do a little bit of rearranging. I end up with 4.9 times 18 is 88.2 divided by, I'm just going to flip these around to make that subtraction in the other spot, 906v minus 2, I just inverted those two, oops, that should go there, is equal to 0.423v. I'm running out of room a little bit. Now I'm going to take this whole term and I'm going to multiply it to the other side. We end up with 88.2, still have some room there, equals 0.423v times 0.906v minus 2. Okay? Excuse me. All right, so where does that lead us? If I do a little bit of multiplication, I'm going to multiply these out. I end up with, I'm going to do this up here, 88.2 is equal to 0.423 times 0.906v. I end up with 0.383v squared. And 0.423 times negative 2 is minus 0.846 v. What's that v there? All right, so I'm left with that. I can bring the 88 to the other side, and I have 0 is equal to 0.383v squared minus 0.846v minus 88.2. All right, so all of that is just algebra. And when I get to that point, I can solve for v. This is a quadratic. So I can use the quadratic equation. Opposite of b, plus or minus b squared, minus 4ac, all over 2a, that one. When I do that, I get two solutions for my velocity v. One of those solutions is going to be positive, and one of those solutions is going to be negative. How do I know which one to pick? Well, we're looking for a magnitude of the velocity relative to the player. And so if we're looking for a magnitude, that has to be positive. We're considering the direction as we look at the components. So we're going to go with the positive answer to this quadratic, and we find that that velocity v is 16.3 meters per second. All right, that's a fun problem. We have to consider a couple of things. It's not just a classic two-dimensional motion problem because we have to recognize this key feature, that the quarterback is moving when he throws the ball. So that's part of the velocity, the overall velocity of the ball. It's added to the velocity the ball is thrown relative to that player. The other key feature is recognizing that the horizontal component of that ball relative to the player is the actual velocity relative to the player times the cosine of 25. So we can use this relationship for that part of my ball's velocity horizontally. Similarly, we want to recognize that the vertical velocity of the ball relative to the quarterback is related to the velocity of the ball relative to the quarterback. So we can use that in that relationship, which allows us to get an equation in terms of the velocity of the ball and time. And in the vertical direction, I get another equation in terms of the velocity of the ball and the time. Once I have two equations with the same two unknowns, I can solve for them through whatever method you prefer. I kind of like substitution, so I solve for the time in one of my two equations, and I substitute it into the second one. And then I solve for the velocity that I'm interested in. Does give me a quadratic, so we need to pay attention to that. How do I know if it's the positive value or the negative value in this case? We'll get both. Recognizing that what we're solving for is a magnitude, so the physical quantity we're solving for only makes sense for a positive value, and so my solution to the quadratic must be positive. And we get 16.3 meters per second. Now the great thing about these problems is you can check them. So we can go back and look, does 16.3 meters per second give me a situation where a quarterback moving at -2 meters per second, throwing the ball at 25 degrees with that velocity, get to 18 meters? And if you do that practice problem, you'll find that it does. All right, good job.